All right, everybody. Today we're talking about limiting reagents. And the first thing is kind of an analogy, if you will. Let's say you have a skateboard. And to build a skateboard, you need to have a deck, one deck, just one of these are the wood things on top. Trucks, you need to have 2 trucks, and you need to have 4 wheels to make one complete skateboard. So if I give you 4 decks and 4 trucks and 4 wheels, how many complete skateboards can you build? You said it, one complete skateboard. So then I asked myself, well, why not? I got 4 decks here. I've got 4 trucks. Well, that's because we don't have enough wheels. The wheels become the limiting reagent. Okay. It determines how many of the complete skateboards that we can make. All right. So a limiting reagent is the reactant that is consumed first and limits how much product can be formed. Let's go ahead and put that into our notes. The reactant that is consumed first and limits product formation, okay? And then all of the other reactants become excess. You have enough of them, okay? The other reactants that you have more than enough of, okay? Okay. So what you're gonna do is I'm gonna give you some time and you're gonna go to FET right here, and you're gonna do the first ones, and you're gonna take this analogy, and this analogy first off is gonna start with a sandwich. So for all people with dietary restrictions, I am sorry, but this right now, we're eating some glutes, we're eating some cheese, some dairy, and if you even want some meat, you can make some meat ones right here. And up top tells you your balanced equation. It tells you the ratio, right? And there's some questions here. So start with 3 bread and 2 cheese. So I'm gonna go like this, 3 bread and 2 cheese. Okay, how many products are made? The products are right here. I have 1 cheese sandwich. Okay, what are the leftovers? Oh, I have 1 piece of bread and 1 cheese. Those are my leftovers. Okay, so then you're gonna go through this and answer some questions. Then you get to this part right here and you say, okay, now I'm gonna click on molecules. I'm gonna say make water. And this is your favorite equation right here. And I'm gonna add a bunch of hydrogen, and then I'm gonna do some stuff. You're gonna write down what you need to do. Okay, cool, cool. So this is the first part. I'm gonna give you all about 10 minutes to do it. Sounds good? Cool. All right, everybody, hardest problem that we've done this year. When 4.22 grams of oxygen reacts with 1.05 grams of hydrogen. So I'm giving you, check this out, the mass of 2 reactants. Anytime I give you the mass of 2 reactants, that should in your brain be like, ooh, which one's the limiting reagent? It's very rare that they're both be exactly consumed. One of them is going to limit the production of water, and the other one is going to be in excess. So 4.22 grams of oxygen reacts with 1.05 grams of hydrogen to produce water. How much water is made and how much excess reactant was left? First step is balance that equation. You know this one just as well as I do by now. We use it so much. 2, 1, 2. All right. Now step 2. The steps, by the way, are up here. Okay, I already gave you the steps, so you don't need to write down the steps. But the next step is turn everything you have into moles. So I have grams of O2. I need to turn that into moles of O2. I have grams of hydrogen gas. I need to turn that into moles of hydrogen gas. Okay, and I'm going to do that right here. I want you all to do it as well. Go ahead and start. Next thing I'm going to do is my little side hustles, right? And so what I'm going to do here is I'm going to say, listen, this right here, the molar mass, 1 mole of O2 is equal to 31.998 grams. So when I do this times this divided by this, then I get 0.0381 moles of O2. Okay. And when I do this one over here, I really wish that. When I do this one over here, I say, okay, 1 mole of hydrogen gas is equal to 2.010 grams, and I get 0.522 moles of H2. So yes, we're using 1.22 here. So now I have this in moles here, and I have moles in here. Now what the deal is, you choose one of them. Okay, it could be oxygen, it can be hydrogen, it doesn't matter. Okay, I'm going to choose this one just because it's a larger number and less decimals. Okay, I'm going to say, okay, I am going to see if I use all of this up, all 0.522 moles of hydrogen gas. So moles of hydrogen gas, how many moles of O2 would I need? Okay. And I look at my balanced equation. I see that it's a 2-to-1 ratio. Okay, a 2-to-1 ratio. So again, this is the big concept here. This is the big point of today. I'm going to say, hey, if let's say for a second, I think that hydrogen is my limiting reagent. If I use up all of my hydrogen, all 0.522 moles of my hydrogen, how many moles of oxygen would I need? So it's 5.22 times 1 and then divided by 2, and I get 0.261 moles of O2. This is the big concept. I said, if I'm using all of my hydrogen, and again, you can do this with oxygen if you wanted to, but if I use all my hydrogen, then I need to have 0.261 moles of oxygen. And I ask myself, do I have that much? And I look at how much I'm given. Oh no, I do not have enough. I do not have enough oxygen. I only have 0.0381 moles of oxygen. And if I were to use all of this up, I would need 0.261 moles. So whichever you don't have enough of, that is my limiting reagent. And the other one is excess. So is there enough of the other product? No. O2 is my limiting reagent. So now we have determined the limiting reagent. Okay, so what do we do now? Well, we do the rest of the problem now. We had to do that only to determine the limiting reagent. Okay, and we're going to use the limiting reagent for the rest of the problem. We said that O2 is my limiting reagent. So we're going to use this right here. We're going to say, hey, that right there is my limiting reagent. And my question is asking me how many grams of H2O was formed, right? Well, I already have it in moles of O2. So let's go from moles of O2 to moles of H2O. And let's go from moles of H2O into grams of H2O. Okay. I look at my balanced equation. There's 2 waters for every 1 oxygen. And I do a little side hustle. I think it's 18.015 grams for every 1 mole. So then I take my calculadora and I say 0.0381 times 2 times 18.015, and I get 1.37 grams of I'm right in the wrong spot, 1.37 grams of H2O. So what I did here is to determine how much excess I have, I said, listen, I know my oxygen is going to be the limiting reagent. Let's turn that from moles of oxygen into moles of hydrogen gas. And that's how much. So that's how much I really need. But how much do I have? Oh my gosh, I have plenty. I have excess. So it's 0.52 minus 0.0762. Okay? And that right there is equal to 0.52 minus 0.0762, and I get 0.4438, 0.4438 moles of H2. All right, so after we have balanced this equation, we're basically going to determine, let's say for a second that nitrogen gas was the limiting reagent. And let's say that nitrogen gas is their limiting reagent. Okay, so we're going to do it both ways, even though technically you only have to do it one. Okay, so this is going to go from moles of nitrogen into hydrogen, and this is going to go from moles of hydrogen into nitrogen. They're going backwards, or they're going reverse, or whatever. So this is all has to do, so moles of nitrogen, there's a 1 in front of it, and moles of hydrogen, there's a 3 in front of it. All right, and moles of hydrogen, there is a 3 in front of it, and moles of nitrogen, there's a 1 in front of it. So now we just do some calculations. Calculator. So I have 3.45 times 3 equals 10.35. 10.35 moles H2. Cool. And then over here, I have 4.85 divided by 3 equals 1.62. 1.62 moles of N2. Cool, cool. I basically, because in this problem, I'm starting with moles, I'm just going to analyze it. So let's look at this. Moles of N2. If all the N2 reacted, how many moles of hydrogen gas would I need? I need 10.35. Do I have 10.35? No, I'm only given 4.85. No, I don't have enough H2. Let's see what the opposite of that. Let's say you chose hydrogen gas and you're like, hey, listen, I think hydrogen gas is their limiting reagent. If I start with hydrogen gas, how many moles of nitrogen gas would I need? Oh, okay. Well, I would need 1.62 moles of it. How much do I have? Oh, I have 3.45 moles. Yes, I have excess. So whichever one you choose will either tell you if it's a limiting or if it's excess, and then the other one is the opposite. You know what I mean? Okay, so which is the limiting reagent? Well, in this case, it was, let's think about it, moles of hydrogen gas. Hydrogen gas. Hydrogen gas. And why was it limiting? Because we needed 10.35 and we didn't have enough. Okay? Because we needed 10.35 moles and we didn't have enough. Pobrecito. Okay? Okay. So, how many moles of ammonia will form? Well, basically, now that I've said that hydrogen gas is my limiting reagent, I can go with my hydrogen gas and do the whole problem. So hydrogen gas right here, I look at it and it's going to go from moles of hydrogen gas into moles of H2O. And I look at my balanced equation and I say that it is 3 of these for every 2 of these. So then all I do on my calculadora is I do a little something like this. 4.85 times 2 divided by 3, and I would get 3.23 moles. Did I say H2O? I meant NH3. So you're saying to yourself, how did it go down? Well, we had 4 skateboard wheels and we ended up with 1 skateboard. It's that these products consist of 4 atoms and these reactants only have 2 atoms each. Yes, more. Okay, cool.